Here's a here's a different type of frequency table. So what we have here is that we have the x values, but we have a range for the x values. So what we're saying here is that the x values go from 0 to 25. And so there's 72 of these values that go from 0 to 25, and we don't know what they are. Maybe they're all 1s, maybe they're all 24s, or maybe they're a mixture of all the different values. Then we have a bunch that go from 25 to 50, 8 of them that go from 50 to 75, and so on and so forth. And the way we treat these frequency tables is we actually take the midpoint of the range. So the midpoint of the range, so between 0 and 25, the midpoint is 12.5. So the midpoint is 12.5. And what we're going to assume that all those 72 values are at 12.5. It's an approximation. It's not necessarily true, but that's how we treat the ranges. So this would be 37.5, this would be 62.5, 87.5, and 112.5. Now, so the n, if we add these guys up, so the n is going to be 114. Now the mode, so essentially, remember, we're treating all these 72 values as if they were 12.5. So the mode is 12.5. If we're finding the median, so if we're going to find the median, so first we need the position. And the position is going to be 114 plus 1 over 2, which is going to be 57.5. And the first 72 positions are here, which means that the median is actually, that's kind of boring. But, so the median will also be 12.5. And then the mean is going to be 12.5 times 72 plus 37.5 times 20 plus etc. going down, all divided by the 114, which is the sum of the frequencies. And it's going to give us 12.5 times 72 plus 37.5 times 20 plus 62.5 times 8 plus 87.5 times 11 plus times 3 equals, that's a big number, divided by 114, and I got 30.26. And so the mean in this case is 30.26, or probably just 30.3.